Hey guys, today we are going to talk about topological sorting of a directed acyclic graph. Consider the problem of scheduling a sequence of jobs based on their dependencies. In this graph, the jobs are represented by vertices and there is an edge from job 0 to job 1 if job 0 needs to be completed before job 1 can be started. Then a topological sort gives an order in which to execute the jobs. It generates a linear ordering of all the vertices of a graph where if there is an edge between vertex u to vertex v, then vertex u appears before vertex v. There is a simple algorithm that generates the topological sort of a directed acyclic graph. We perform the DFS, the depth first search of the graph, and output the vertices as they get finished and add them in front of a linked list. We say a vertex is finished when its adjacency list is completely examined. Now let us perform the topological sort of this particular graph presented here. First, we visit vertex 0. Then we explore its adjacency list. We find vertex 1. Then we move down and explore its adjacency list. We find vertex 4. Vertex 4 does not have any outgoing edges, so it is finished. We output vertex 4 and add it in front of our empty linked list. Now we go back to vertex 1 and find that vertex 1 has no more edges, so we output vertex 1. Now we again move back and explore the remaining edges coming out of vertex 0. We find vertex 5 and then from 5 we move to vertex 2. Then from 2 we see that there are no edges coming out of vertex 2, so we output vertex 2. So vertex 2 is now finished. Now recursively we move back to vertex 5 and vertex 5 now has no outcoming edges, so it is also finished. Now we go back to vertex 0 and find that vertex 0 is finally finished. So now we add it in front of our linked list. After that we are free to explore any of the vertex. Let us pick 3 and we find that out of the 4 edges coming out of vertex 3, 2, 5 and 4 are already in our output. So 6 is the one remaining. We visit 6 and then from 6 we go to 4. 4 is already finished. So now we go to 0. 0 is also finished. That means vertex 6 is finished. We output it and add it in front of our linked list. Now we move back to 3 and see that 3 is finally finished. Guys, we have completed the topological sorting of this particular graph. If you look carefully in this particular order, then you will find that every vertex is going from left to right. For example, in case of 3 to 6, this particular edge is going from left to right. Even for 6, this particular edge 6, 0 is going from left to right, and so on for the rest of the vertices. Now there are 3 more points that I would like to touch in topological sorting. First is the runtime complexity. It is easy to guess that the runtime complexity is same as of the depth first search, which is order of number of vertices plus number of edges. Second point is that topological sorting is possible only in directed acyclic graphs. If there is a cycle, then topological sort is not possible. The third point is that there can be multiple topological sort orders of a particular directed acyclic graph.